Okay, so today we're going to be looking at ions. Okay, but before we look at ions, let's have a look at our atoms. Here's an atom, it's got a neutral charge. It's got the same number of positively charged protons and negatively charged electrons. Now, what happens if I rip off an electron?
Ouch!
Sorry. Now I have a different number of protons to the number of electrons. My atom no longer has a neutral charge. So that's our definition of an ion. An ion is a charged atom. Ions can be positively charged. Ions can be negatively charged. It all depends on if we're adding or removing electrons from our atom. To explain, let me recall what our old chemistry teacher used to say. Electrons are like your worries. If you add more of them, you become more negative. If you get rid of more of them, you become more positive. She was northern. Sorry, Miss Allen. So, with ions, it is my electrons' time to shine. We can add or remove electrons from our atom and change the overall charge of our atom. So, if I take an atom and I remove some electrons, now I have more protons than electrons and I'm positively charged. However, if I take an atom and I add electrons, I have more electrons than protons and I'm negatively charged. Quick example, have a look at this lithium atom. What is going to happen when I remove 2 electrons from my lithium atom? Now I have 3 positively charged protons and 1 negatively charged electron, so I have an overall charge of +2. Okay, now we need to look at how the electrons move. They move in 2 ways. Number 1, friction. You can literally rub electrons from one material to another. Number 2, they can be zapped off sci-fi style. Electrons in the outer shell can be struck by electromagnetic radiation. The electrons in the shell can then absorb that energy from the radiation. They then can use that energy to escape the atom. Once they've left, they leave behind a positively charged ion. Okay, but it gets weirder. If an electron in a different shell absorbs some energy from an electromagnetic wave, they can use that energy to move up an orbit or 2. Okay, now it gets even weirder. If one of those electrons now falls back down from a higher orbital to a lower orbital, then it loses energy and it releases the energy that it loses in the form of electromagnetic radiation. It's true. Real life magic. Okay, let's have a little look at an exam style question.
So, in this question, I have to use the words from the box to complete the sentences. Atoms may form positive ions by losing electrons, by losing that negative charge and those negative worries. The electrons involved in forming positive ions are my outer electrons. The outer electrons absorb the electromagnetic radiation and then they can escape the atom. Now I have to fill in the table below. So the first column is the mass number. Remember, that is my top number, so in this case it's going to be 39. Atomic number is the number of protons and it's my bottom number, so that's 19. As I've just said, the number of protons is equal to my atomic number. Now, for my number of neutrons, I need to take my mass number, which is 39, minus my proton number, 19, and that gives me 20 neutrons. Now, this particular ion has a charge of +2, which means that it must have 2 fewer electrons than the number of protons. So I can say that it must have 17 electrons, which gives it that overall charge of +2.